Okay, question number 6 on the review for exam 3 is a Laplace transform. And here we can do this piecewise defined function one of two ways. We can use the definition of a Laplace transform. So we could say the Laplace transform of f of t is the integral. Let's see, this is broken up into two different intervals, 0 to 1, and then I have e to the negative st times f of t. On this first part, we have negative 1 dt, plus on the second part, we have 1 to infinity, e to the negative st times 1 dt. And then I'm going to, off to the side, let s be greater than 0, so that that exponent goes to 0. When I substitute in infinity on this first part, it shouldn't matter. So here the integral of e to the negative st is just e to the negative st divided by negative s. That negative 1 carries along, and we're going to have our limits 0 and 1. On the second part, again, the integral of e to the negative st is e to the negative st divided by negative s. And here we have that limit st goes to infinity. This is when we'd want to let s be greater than 0, so that that limit will go to 0. And then substituting in, on this first term, those two negatives cancel each other out. So I just have e to the negative s over e to the negative st over s. Substituting in 1, I get e to the negative s times 1 over s, minus substituting in 0, we get e to the 0 over s. Let me change that. On the second part, we have the limit as t goes to infinity of e to the negative st over negative s, and then minus, when we substitute in 1, we get e to the negative s over negative s. On that second term, those two negatives will cancel. And then on this first term, as t goes to infinity, because that exponent is going to go to negative infinity, e to negative infinity is essentially 0. So this whole first term goes to 0. And that leaves me with, notice that this first and last term are identical, leaves me with 2 e to the negative s over s minus 1 over s. If you want to, you could combine those into a single fraction. You don't really have to. So that's 6.